Welcome you all. In this lecture, we are going to discuss indices, right, from plasticity index, flow index, toughness index, and many. So, in fact, plasticity index, we repeatedly telling you, plasticity index is equal to liquid limit of soil minus plastic limit of soil. Actually, it is designated with IP, or sometimes people use it to write PI. Next, flow index, as we discussed in the liquid limit topic, flow index is the slope of the flow curve, W1 minus W2 by log 10 N2 by N1. Many times I used to tell you why you are writing N2 by N1, because it is a downward trend. As the water content increases, number of blows decreases. So that's why we are writing here N2 by N1. Otherwise, you can write minus, but don't forget to write N1 by N2 if you put minus. So next, toughness index, it is also already we discussed. It is a ratio of plasticity index to flow index. Just now we discussed plasticity index. Just now we discussed flow index also. So now IT is equal to IP by IF. It's very interesting to discuss. Toughness index is a measure of shear strength of soil at plastic limit. So a soil having higher toughness index, it is having good shear strength. Now here you see that's what it is indicating. That's why it is called index. It is indicating toughness of the soil. Now here I'm going to discuss about very interesting and very important parameters, those especially when you are dealing with the soft soils, especially marine clays. Here you see I have consistency index IC. IC is equal to WL minus WN. I want to write W suffix N by IP, PI, whatever you want to write, you can write here. So here you see IC is the consistency index of the soil. IC is equal to WL minus WN. WL is, everyone knows, it is liquid limit of soil. WN is the natural moisture content. Natural moisture content of the soil by IP. What do you mean by IP? Liquid limit minus plastic limit. So now WL minus WN. So let us check now our knowledge about understanding the consistency index. So now you see, if natural moisture content is equal to plastic limit, what is the consistency index? WL minus WP by WL minus WP. Now it's going to be a 1. Let me tell you 100%. For example, your natural moisture content is equal to liquid limit. What will happen to consistency index? 0. The reason is very simple. Here you see natural moisture content is equal to liquid limit. So liquid limit minus liquid limit. See, whenever your natural soil, natural water content in soil is equal to liquid limit, where the consistency of the soil is 0, there is no need to surprise here. The consistency of the soil becomes 0 when your natural moisture content equal to liquid limit. So you see, this is a very interesting fact. We are ready to accept now. Whenever you see natural moisture content is equal to liquid limit, so then the soil loses its consistency and it's almost 0. So the water content is now equal to liquid limit. Don't expect this situation. If this has happened, then we call it as a very soft soil. So here you see liquidity index. In fact, you see many times I use it to tell my students, liquidity index is opposite to consistency, 1 minus IC. Because liquidity is opposite to consistency. A soil having 50% consistency means 50% liquidity is there. So I can write now comfortably 1 minus, here we already discussed the consistency is WL minus WN by IP, as you know, WL minus WP. Now if you rearrange this equation, what we are getting, there is no need to surprise. WL minus WP minus WL minus WN. So it is very interesting to see by IP, liquid limit minus plastic limit. Here you see the liquid limit are going to be cancelled. Now you see what I am getting now. WN, this you see actually this minus into minus became plus. Now what I am getting is WN minus WP by IP. So this is very interesting. No need to remember this equation. First, you try to think about how to understand consistency index. Whenever your liquid limit is equal to whenever your natural moisture content of the soil is equal to the liquid limit, the soil loses its consistency because your natural moisture content is rising, and sometimes it may reach the liquid limit. This could happen in soft soils, especially very soft soils. So like marine clays. Here you see, then consistency is 0. Now I'm telling consistency, then liquidity. Liquidity is opposite to consistency. So if you sum up IC plus IL is 100%. So now how to get IL? 1 minus IC, 1 minus WL minus WN by WL minus WP. Now if you see here, this minus and minus become plus. Now what I'm getting at the end, W minus WP, plastic limit by plasticity index into 100. So this is the way we should understand consistency index and liquidity index. Especially these index are very useful to identify the consistency of the soil, whether it is liquid state or plastic state, or you can understand whether it is firm state. Here you see. So now let us proceed now. The same discussion here I want to show you. But my interest this time is I want to solve a numerical example for better understanding. So now plasticity index, liquid limit minus plastic limit. So here consistency index, I want to write consistency index, liquid limit minus natural moisture content. I will tell you once again how to understand this equation. Whenever natural moisture content is equal to liquid limit, consistency is 0. So don't expect that situation. So now liquidity is opposite to consistency, 1 minus. So if we add together, we will get 100. Toughness index, it is already explained, IP by IF. IF is already explained. So slope of the flow curve. Now let us solve a numerical example without further ado. A soil has a liquid limit 25, flow index 12.5, plastic limit 15, determine plasticity index. Whenever we got chance to determine plasticity index, don't hesitate to write this. Plasticity index is equal to liquid limit minus plastic limit. So here it is given 25, liquid limit, plastic limit is given 15, 25 minus 15, obviously 10%. Now the questionnaire has given flow index. From this, it is possible to determine toughness index. Just now we discussed toughness index is a ratio of plasticity index by flow index. Probably you see, we have our knowledge. We try to think first about how to determine plasticity index. If you determine plasticity index, it is very easy to determine toughness index. So whenever you are solving this type of question on indices, please concentrate on determination of plasticity index at the first. Afterwards, toughness index. Now here you see consistency index. As I told you, WL minus WN by IP. I am ready to tell you once again, whenever natural moisture content is equal to liquid limit, then consistency is 0. So now WL minus WN by IP, 25 minus 20 by 10, 50%. If consistency is 50, what about liquidity index? Many students ready to tell now, liquidity index is 1 minus IC. 1 minus 0.5 is 0.5, now it is 50%. Now, with the same interest, I would like to present you a few more indices. One is activity of soil. This is very useful. Many times, many researchers are also many geotechnical engineers, civil engineers, they are using this expression to identify the swelling nature of soil. Activity is widely used by many countries following this activity number in order to identify whether soil is expansive or not, swelling or not. Here, what do you mean by activity? Activity is also a ratio of plasticity index by percentage clay. I will ready to tell you without any further delay. I can tell you activity is a ratio of plasticity index to percentage clay. Someone can surprise, sir, I'm seeing here clay fraction. Here F means clay fraction, where you know the clay having particles having less than 2 micron size, less than 2 micron size. So IP by percentage C, which is we are trying to write as activity. Activity is an indicator of swelling or shrinkage of a soil. If activity is less than 0.75, it is inactive soil. So if activity value is 0.75 to 1.25, normal soil. If activity is more than 1.25, it is active soil. It is prone to swelling and shrinkage. So that's very important. If activity is more, we can suspect the soil is expansive soil, or what you call swelling soil. So here you see the another parameter. In fact, it is index, which is also used in many times for the benefit of civil engineering. That is sensitivity. Sensitivity is very interesting. I will explain Sensitivity is ratio of strength of the soil in the undisturbed condition by strength of the soil, in fact, shear strength of the soil in the disturbed condition. Sometimes people ask me, well, sir, what do you mean by undisturbed condition and what do you mean by disturbed in the sense of remolded condition? See, undisturbed means intact condition, natural condition. Whereas sometimes you use it to compact the soil, then it is called remolded clay. So sensitivity is a ratio of shear strength of soil in the undisturbed condition, that I am trying to say, intact condition. And QU, one can easily say divided by disturbed condition. That means I am trying to say disturbed means recompacted. What I say, remolded. So now sensitivity, here you see it is less than 1, insensitive. If it is more than 16, it is quick. So if sensitivity is more, one can say based on that we can classify the soil. That's the advantage of sensitivity. Now it is time to discuss the last one in the indices, thixotropy. Thixotropy. So here actually thixotropy is having, here two words are there here, thixis plus tropo. Thixis means touch. Tropo means change. By touching, it is going to be changed. So this is very interesting thing. Actually, here you see many times, especially in soil engineering, we used to use this concept thixotropy. Very interesting, the loss of shear strength of soil due to remolding. I told you, due to remolding means compacting. So again, you see, soil, you see, if it is intact condition, we know its strength. Once it is disturbed, there may be, what I say, its strength will be reduced. But after recompacting, again, it's regaining its strength with time. The property of a soil to regain its strength with some time, with time, is called thixotropy. Thixotropy is an interesting parameter. Many times we use to study in fluid mechanics also. Thixotropic material, thixotropic fluid is paint. As you know, if you paint a wall, so if you, within just a second, if you put your finger, you can touch it. By touching it, there will be a change. That is called thixotropy. So once you see, after some time, if you touch the paint, it won't be in touch with your finger. So that means paint has got its strength after some point of time. So now it has regained its strength. So that, so even in soil also, where we use it to make pile foundation in soil as a foundation. So if you immediately see, if you see the neighboring soil is disturbed due to making pile, but after some time, the neighboring soil will regain its strength with time. So this is what thixotropy. It has a lot of practical significance in day-to-day civil engineering problems. Thank you all.